Hello. In this video, I will present our project on flood vulnerability mapping of the Flemish road network using QGIS. We all know that climate change is causing heavy rainfall events to occur more frequently, which increases the risk of flooding, especially in urban areas. At the same time, urbanization in Flemish cities such as Ghent, Leuven, and Antwerp has led to a growing amount of impermeable surfaces such as roads and buildings. This reduces water infiltration and increases pressure on drainage systems, raising the risk of flooding on urban roads. In this study, we are investigating which parts of the road network are most vulnerable to flooding using spatial data, elevation differences, and drainage patterns, with the aim of supporting climate resilient urban planning. In this project, QGIS was used to analyze flood risks by combining vector data, such as roads and urban features, with raster data representing flood depth and exposure. The analysis focused mainly on pluvial flooding caused by heavy rainfall in urban areas, while also considering fluvial and coastal flooding. All datasets were processed using a consistent coordinate system in QGIS, and road networks were buffered to better reflect their actual width and improve spatial overlap with flood-prone areas. To analyze flood exposure, the continuous water depth data in QGIS was simplified into three severity classes. Areas with a water depth of less than 30 centimeters were classified as low impact. Depths between 30 and 70 centimeters were considered medium impact, and depths above 70 centimeters were classified as high impact. The raster data was then reclassified according to these thresholds and converted into vector polygons to make it possible to compare it with the road network. The results show that most of the study area falls within the low risk category, while smaller zones are exposed to medium and high flood risk. After determining the flood depth classification, a vulnerability classification was assigned to the flooded road segments based on the flood depth and the road type from the highway field. This classification combines flood severity and road importance into one indicator with three classes: low, medium, and high vulnerability. Primary and secondary roads exposed to severe flooding were considered the most vulnerable because disruptions on these roads have a greater impact on mobility and accessibility. The results show that most flooded road segments belong to the low vulnerability class, while smaller areas were classified as medium or high vulnerability. The final results are presented through two types of maps, designed to clearly visualize both the spatial distribution and the relative importance of the vulnerability classes within each city. The first type is the study area map, which provides an overview of the three cities examined in this research. This map highlights their size, location within Flanders, and their spatial relationship to one another. The second type consists of detailed city maps. These maps focus on the urban areas with the highest exposure to water and the greatest combined vulnerability, identified through visual assessment. Particular attention is given to the city centers and the most vulnerable zones. In addition, key infrastructure that must remain accessible during extreme flooding events is displayed, including hospitals, police stations, fire departments, and pharmacies. Together, these maps form the basis for evaluating the potential future applications of the vulnerability data and its relevance for flood risk management and urban planning. Well, based on these results, we can now draw several conclusions. Higher water depths combined with primary and secondary roads resulted in the highest vulnerability classifications, while most road segments overall still belong to the low vulnerability class. We also noticed that Leuven showed the highest percentage of medium vulnerability roads, whereas Ghent contained the largest proportion of highly vulnerable roads. In addition, medium and high vulnerability roads were mainly concentrated near major intersections, which further increases their importance within the road network. Finally, we observed that several vulnerable road segments are located close to hospitals and emergency services, highlighting the potential impact that flooding could have on accessibility during emergency situations. This is the end of the video. Thank you for watching.